Alright, so next up we have a demonstration. And the challenge here is we have two boxes 12 inches apart. Our goal is to span the distance between these two boxes using only 15 popsicle sticks. So for this one, I'm going to need a volunteer. Come on up.
Hey.
What's your name?
Kai.
Hi, Kai. Ooh, okay, let's slow that down. And push against me. What are we doing?
Pushing each other.
Okay, and what's another word for pushing on something?
A force?
Yeah, to apply a force. Okay, let's hold this nice and still. So why do you think, I'm pushing on you and you're pushing on me, but why do you think we aren't moving?
Because we're both solid objects and we're pushing the same amount. Okay,
yeah, so the forces that we're applying to each other might be equal. Let's try look at this another way. So I have my eraser, and we're on Earth, so we have gravity. Have you guys learned about Newton's second law yet?
F equals ma?
Yeah, so Newton's second law says that a force happens when you have an object with mass, like this eraser, that's subjected to acceleration. So in this case, Earth's gravity. So when I drop it, it falls to the counter and stops. Why do you think it stopped moving?
Because the counter's solid.
Sure, and because it's solid, that means it can push upwards on the eraser, right? So in both instances, when we have the eraser on the counter at rest, or when we're pushing at each other and not moving, we're at a state of equilibrium, which means our forces that are acting on the object are equal and opposite, so they're balanced. This is like a really common concept in statics and dynamics, and which is very applicable in mechanical and civil engineering. So let's see if we can use that with this information to build a bridge.
Okay.
So we don't have glue or tape, but we have a design invented by a guy named Leonardo da Vinci in the 1500s that we're going to give a go, okay?
Okay.
So I'm going to get you to help me hold these popsicle sticks in place. We're going to make a little crisscross pattern here.
Okay.
And I'm going to put this one here and this here. And can you just hold them for me as I go?
Sure.
Thanks. And then once we start moving through, we're going to start to tilt it up a little bit, all right?
Okay, sounds good.
So we're going to start here. You got it?
Yep.
Okay, yeah, hold those two in place. Let's tilt it up a little bit. We're going to stick another popsicle stick under. Perfect. And same thing, under and over, so it's nicely wedged in place. Wonderful. Okay, another one on top. Good. And then we're going to go under and over. Good. Got it? Under and over again. So I think one last time I'll do it here. Stick this here. Again, we're gonna go under. Got it? Under and over, and under and over. And let's just spread that out a bit so it has a solid base. Let's see if this works. Ooh, nice. Okay, so we built a bridge. It's not moving. Do you think there's forces acting on this bridge?
Maybe not. Maybe yes.
Okay, so going back to Newton's second law, a force is a mass. So in this case, our popsicle sticks have mass, and we're on gravity, so it's subjected to Earth's gravitational field, right?
Yeah.
Okay. So there's indeed forces acting downwards on it caused by gravity.
Okay.
So why don't you think it's falling down?
Probably because these boxes are solid.
Careful. Yes, so the boxes are solid. They can, just like we saw before, exert a positive upwards force, which counteracts the force of gravity, which is why we're at equilibrium. And the popsicle sticks transmit the force to each other, which is why it's stable. What do you think would happen if we had this?
Might collapse, it might not.
Alright, let's see. Okay, we're good. So again, there's still forces acting on it, right? And it's still balanced, which is why it stays still, right?
Yeah.
So this is what engineering is all about. It's about taking a really simple, or sometimes complex, scientific principle and applying it to solve a practical problem like this. Alright, thanks so much for your help.
No worries.
Alright, see ya.